Unit 4, Lesson 7, Solving Trig Equations Part 2. So in the last lesson, we learned how to solve for theta when given the trig ratio, right? We were given things like sine theta equals 1/2, find all values of theta. Now in today's lesson, we are given the angle and we are asked to find that ratio. Okay, so let's get into some examples. So find the ratio or evaluate sine of negative 30 degrees. So the first thing you're always going to want to do is draw that on a diagram. Okay, so there is negative 30 drawn on our Cartesian plane. Okay, so step 1 is draw the rotational angle. Step 2 is find the related acute angle. Okay, so we know in this case our related acute angle is going to be the positive version of our principal angle. So our related acute angle here is going to be equal to 30 degrees. Now we're going to use that related acute angle to find the numerical value of the ratio. Okay, remember our goal is to find the ratio. So let's go ahead and do that. So what is sine of our related acute angle? Sine of 30. Okay, and using your special triangles, you're going to realize that sine of 30 is 1/2. Okay, so we know the numerical value of our ratio is 1/2. Now we just need to figure out if that ratio is positive or negative. Okay, so our last step is assign a positive or negative sign to your ratio. Okay, and the way we do that is we look at where the terminal arm of our rotational angle lies. So our terminal arm of our rotational angle was in quadrant 4. Okay, is sine positive or negative in quadrant 4 using your CAS rule? Okay, you're going to realize that sine is negative there. So we assign a negative sign to our ratio. And now we're done the question. We know that sine of negative 30 is equal to -1/2. Okay, let's try tan of 315. Let's follow our steps. First, draw the rotational angle. So draw 315 degrees. Okay, step 2 is find the related acute angle. So the related acute angle is going to be 360 degrees minus 315 degrees, and the leftover piece is your related acute angle. Okay, step 3, use that related acute angle to find the value of the ratio. So tan of 45 degrees is equal to 1. And we know that using our special triangles. Okay, so we know our ratio is equal to 1. Now we just need to do step 4, assign a positive or a negative to that ratio. So is our 1 negative or positive? So let's look at the terminal arm of our rotational angle. Okay, it's in quadrant 4. Is tan positive or negative in quadrant 4? Okay, tan is negative. Using our CAS rule, we know that tan is negative in quadrant 4. So we assign a negative to our ratio. And now we're finished. Okay, let's solve cos of 390 degrees. So first, draw in the rotational angle. Okay, so 390 degrees, that's one full rotation, right, 360, plus another 30 degrees to get to 390. Okay, so now step 2, find our related acute angle. So our related acute angle is going to be the principal angle, 390 minus 360, right? So beta is equal to 30 degrees. It's a related acute angle. Now step 3, use the related acute angle to find the ratio. So cos of our related acute angle, cos of 30 is equal to √3/2. How did I know that? I used my special triangles. Okay, so we know our ratio is √3/2. We just don't know if it's positive or negative yet, so let's figure that out. Our terminal arm of our rotational angle ended up in quadrant 1. Is cos positive or negative in quadrant 1? It is positive. Using that cast rule, we know it's positive. So our final answer is cos of 390 degrees is equal to root 3 over 2. Okay, example 2. Determine all the solutions in the indicated interval. So this is kind of like what we did in our last lesson, right? We're given cos theta is equal to -1/2, and we need to solve for theta. So let's start by figuring out our related acute angle. I'm going to do that by taking the positive value of the ratio. Okay, and using our special triangles, I know that my value of my related acute angle is 60 degrees. Now let's figure out, where is cosine negative? Okay, according to the cast rule, cosine is negative in quadrant 2 and 3. So let's draw terminal arms in quadrant 2 and 3 with related acute angles of 60 degrees. Okay, so that means that our first value of theta is going to be 180 plus 60 degrees, and our second value of theta is going to be 180 minus 60 degrees. Okay, so theta 1 is going to be 240 degrees and theta 2 is going to be 120 degrees. Okay, pause the video and try this one on your own. There is some rearranging that you need to do first. Remember, if you need help, think of it as this. You have 4x plus 3 equals x. Okay, think of tan theta just as x, right? And to simplify this, you'd want to get both your x's on the same side. So I would bring, this is technically a 1 tan theta, bring it over here and subtract it from 4 tan theta. Okay, so the very first thing you want to do in this question is you want to simplify, right? You want to isolate for tan theta. Okay, so you should get tan theta equals -1. Then you're going to find your value of your related acute angle, and in this case you can use your special triangles. So you're going to realize that beta is equal to 45 degrees. Okay, then you go back to your original ratio and you ask yourself, where's tan negative? Because the ratio in the original question is negative. Well, tan is negative in quadrant 2 and 4. So you're going to draw terminal arms in quadrant 2 and 4 and make sure that those terminal arms have a related acute angle of 45 degrees. Then using that, you calculate your value of theta. Okay, so in the first one, it was 180 degrees minus the related acute angle. In the second one, it was 360 degrees minus the related acute angle. And then, because our domain extends in the negative direction, we're going to subtract 360 from those original two values of theta and see how many more values of theta there are. So in the end, there were 4 possible values of theta. Okay, please pause the video and try this last one. It does require some simplification first, and the domain has been extended to 720 degrees. Okay, so hopefully you got the same answer as I did. The very first thing you want to do is simplify. Okay, and you would have got sine theta is equal to root 3 over 2. Then you're going to find your related acute angle using the positive version of the ratio, which it already was positive, and you're going to use your special triangles for this one. So you get 60 degrees is your related acute angle. Then you're going to ask yourself, where is sine positive? Well, sine is positive in quadrant 1 and quadrant 2. So then you're going to draw terminal arms in quadrant 1 and 2 and make sure that those terminal arms have a related acute angle of 60 degrees. So that's what I've done here. Then you're going to find your values of theta 1 and theta 2. So theta 1, because it's in quadrant 1, is just the same as your related acute angle. Theta 2, because it's in quadrant 2, you're going to take 180 and subtract 60 degrees, which is your related acute angle. And you get 120 degrees. Now, because our domain goes up to positive 720 degrees, we want to investigate to see if we can find more values of theta. And we're going to do that by adding 360 to our original 2 values of theta. So that's what I did here. When I add 360, I get 420, which is still within that domain. And then I add 360 to my theta 2, and I get 480, and that's still within the domain. Okay, you could keep adding 360 to make sure you've got them all, but you are going to realize that as soon as you add 360 to 420 or 480, you get a value bigger than 720. So you know you are finished. Okay, so for this question, there are 4 possible answers for theta.